Hello everyone, welcome back to yet another session on concept learning with MathBuddy. Today we are going to be looking at area of a circle, right? So we are going to use this instrument called area of circle kit, and if you open this you will see some red and blue pieces. So I have got some blue pieces and some red pieces. I have arranged both of these in the form of a circle. So go ahead and arrange both of these in the form of a circle. Let's keep the blue pieces separately for now. Let's use the red pieces, right? And we are going to derive the area of a circle, right? So to get started, what I have done is I have arranged these in the form of circles, in the form of a circle, and I have just marked the ones on top, the pieces. So basically this is something which is divided into 16 pieces. So the entire circle is divided into 16 pieces, and I have marked the 8 pieces on top with a dot on them, right? You'll see why I have done that in a few minutes, right? Now before we do anything, what is the circumference of the circle? So let's say the radius of the circle is r, right? What is the circumference of the circle? Circumference of the circle is 2 times pi r, right? Let me just write it down here. So circumference of the circle is 2 pi r. We all know that, right? What is the circumference of half the circle? Let's say that I want to take half of this, only this much. What is the circumference? This should be nothing but pi r, right? 2 pi r divided by 2. Correct? Okay. Now, just remember that. We'll use that in a few minutes. What we are going to do is, we're going to rearrange these pieces in the form of a parallelogram. How do we do that? You take each of these pieces, you place it like this. You take one piece from the bottom and one piece from the top, and let's arrange them, right? So, next one would be something like this, right? And the next one would be from bottom, and the next one would be from the top, and then the next one would be from the bottom, and then from the top, and then from the bottom, from the top. So let's move this a little bit this side, right? And then from the bottom, from the top, from the bottom, from the top, from the bottom. Again, let's move it a little bit to this side, and last one from the top, and last one from the bottom. Okay, so we have taken all the 16 pieces and we have arranged them in the form of a parallelogram. Let me just quickly rearrange them. Okay, so okay, very good. So why do we do this? Because we know the area of a parallelogram. We know how to find the area of a parallelogram. What is the area of a parallelogram? Area of the parallelogram is base into height, right? So what is the base? If you know parallelogram, the base and the top face are exactly the same, and you can see that all the things that I marked on top, they are all here on top, right? All the ones that I've marked with the black dot, right? What was the length of half circumference? That is where all the pieces on top were showing up, right? I have taken all those pieces, arranged them in a line. So the length here must be same as my half the circumference, which is pi r, right? So let me just quickly erase this. Oops. Right? So what is the length here? This is nothing but pi times r. And what's the height? What is the height of this? That is nothing but my radius, right? So this is nothing but the radius of the circle. If you go, this was the center and this is the circumference. So this is basically the radius. So height of this thing is nothing but the radius. The length was pi r, right? What is the area of the parallelogram? It's base into height, right? So this is r, this is pi times r, and therefore the area of the parallelogram is base into height, which is pi r into r, or pi r square. Pi r into r gives us pi r square. So that's how we find area of a circle. And this is true for any circle. You can try the same thing with the blue pieces and make sure that the same thing holds good. Okay, so that's how we do area of a circle. There is one more thing that we can do with this, right? So what we will do is, let's arrange these pieces. Let's take the blue pieces for this, right? So we've got the blue pieces arranged in the form of a circle. Let's take them, right? Now, the area of the entire circle is pi r square, right? And let's say I want to find the area of only a sector of a circle. What do we mean by a sector? So each of these things, this is called a sector, right? And if I take two of these things, that's called another sector. If I take three of this, that's a bigger sector. And let's take four of these things, which is exactly equal to quarter of a circle, right? Each of these things is called a sector. If I want to find the area of the entire circle was 360 degrees. We just saw that, right? Now, the area of the entire circle is pi r square, right? Now, I want to find the area of this sector. How can I do that? The way we do it is, the entire circle if you take, right? If I start from the center, if I go around all the way, the angle it's occupying is 360 degrees, just like your clock. You start from this point, you go all the way around and come back here, you will cover 360 degrees, right? Now, if I take only a portion of it, right? What angle does this occupy? The whole thing was 360 degrees. This occupies 90 degrees, right? It's just like quarter of a clock, right? So for 360 degrees, it was pi r square. Now for 90 degrees, how much is it, right? So we do 90 degrees divided by 360 degrees times pi r square, okay? So whatever is the angle occupied by the sector divided by 360 degrees times pi r square will give you the area of the sector, right? If I have, for example, if I want to find the area occupied by only this sector, then what will we do? So the way we do that is, the entire circle is composed of 16 parts, right? Now each part, so entire circle is 16 parts. So each part has to be 360 by 16, right? The entire circle is 360 degrees. So this has to be 360 divided by 16 should be this angle, right? So we write that there. So 360 divided by 16, whatever is that angle, that divided by 360 degrees give times pi r square. And if you simplify this, you will see that it is nothing but 1 by 16 times pi r square. You can measure the angle if you want, and you can do it that way also. Or you can say that the entire circle is divided into 16 parts, and therefore each part is 1 out of 16. The entire circle is pi r square, so 1 out of 16 is 1 out of 16 times pi r square, okay? So you can do a lot of stuff with this particular instrument. And again, to find the radius of this, so each of these things you need to find the radius. So you can just take a ruler and measure the radius, right? So I hope you enjoyed this activity. If you have any questions, write to us at support@mathbuddyonline.com. Thank you.